Hey y'all, we're continuing on with our 4.1 notes and graphing quadratic functions. Today we're focusing on vertical and horizontal transformations. And that's mostly going to be the shifts left and right, up and down. So again, we always start with this function. Oh, that was weird. We start with this function, f of x equals x squared, for parabolas, quadratic function, and then these values are 4, 1, 0, 1, 4. But really, like we learned in the last one, we really only have to focus on these three because these points, get reflected. All right, and then the graph looks like this. So we have 0, 0, 1, 1, 2, 4. Oh. It gets graphed. And then here's our axis of symmetry. So these points get reflected over. Okay. Again, here's vertex form where A is a vertical compression or stretch. When A is negative, it reflects it over the x-axis. H shifts it left and right, and K shifts it up and down. HK is the vertex. X equals H is the axis of symmetry. We have a max when A is negative and a minimum when A is positive. Okay, so those key things there too. All right. So these two are kind of review of day one. Let's do one of these together. Okay, so looking at my graph, this minus 3, if you remember inside the parentheses, that minus 3 is going to move it left or right, or the inside the parentheses moves it left or right, and that minus is going to move it to the right 3 units. So I'm going to write out what my parent function is. I have 0, 1, 2, 0, 1, 4. And then over here, I'm going to say that my, my function is going to be f of x equals 1x minus 3 squared plus 0. So my vertex is going to be positive 3, 0. Because of that minus there, this is a positive 3. And then my axis of symmetry is going to be x equals 3. So let's graph that. So here I have 3, 0. You know what? Let's move this line over just so we have a little bit of room. So here's 3, 0. Then my axis of symmetry is going to be here. Just want to label this point over here as 0, 0 so we're not confused. And let's do our graph. So x and y. Now if we're moving to the right 3, we're going to add 3 to each of our x values. So we get 3, 4, 5, and these values for y stay the same. So I have 3, 0, 4, 1, and 5, 4. And then those points get reflected over. I'm able to graph, that's not quite good. My function, goodness. remember to make it curved and not pointed. And because of that, we have a minimum. Okay, let's look at this next one here. First of all, Miss B made a mistake, and this squared should have gone over this. So go ahead and make that correction. Okay, so my vertex is at HK. You know what? Let's actually change this to a plus. So I'm changing this problem to a plus right here. And I'm going to rewrite my equation as f of x equals 1 times x minus negative 2 squared plus 1, to have it in that x minus h form. So my vertex is negative 2, 1, and my axis of symmetry is x equals negative 2. Because this is a plus, it's moving to the left. So that's why that's a negative there. Draw my lines over here. All right, and this is the point 0, 0. So we'll graph negative 2, 1, my axis of symmetry. Since there were no shifts, we really don't have to use this if we don't want to. If you understand what the shape of a parabola looks like. Otherwise, you can transform these points. We have x and y. My x values, I'm subtracting 2, and my y values, I'm adding 1. So I get 2, 3, 4, and then 1, 2, 5. So 2, 1, 3, oh, wait. I didn't do that right. Negative 2. I added 2. Negative 2, 1 minus 2 is negative 1, and 2 minus 2 is 0. So negative 2, 0, negative 1, 2, and 0, 5. Then I reflect those points over, and as you can see, my graph got shifted left 2 and up 1 from the vertex. So it went from left 2 and up 1. Okay, and we do have a minimum value for that one. All right, the rest